So, hello everyone. Today we are going to start with the next module, that is a machine learning basics actually. So, in that we are going to cover 6 sub-modules or 6 topics. I'm just listing over here. First one will be a Numpy, just a library from Python. Then second one is a Pandas. Third one is a actually it's a data visualization, but in that we are going to implement two important libraries, data visualization. So in that we will see the Seaborn and Matplotlib. These two libraries for the data visualization. After that we will see the linear regression, basic regression algorithm from the machine learning. Second thing, logistic regression, which is classification based algorithm, basic classification based algorithm. And next one is the k-means clustering. So in this, actually linear and logistic, these are the supervised algorithm. K-means clustering is unsupervised algorithm. In this supervised one, linear is used for the continuous data only and logistic is used for classification data only. So this will give us the overview for the whole machine learning thing, the basic foundation. Okay, so these 6 things we are going to cover in this module, that is a machine learning basics. So today we are going to start with the first topic, that is a Numpy. Okay, and some of the part will be completed today, right? So we'll start with the Numpy first. It stands for the numerical Python actually. Numpy stands for numerical Python. So first of all, I will make it as a heading. Numpy. Okay. So I will write some of the theoretical thing related to it. Numpy is nothing but numerical Python. It's a numerical Python. Okay, stands for a numerical Python. One of the module or one of the important library from the Python. Without Numpy, Pandas, Seaborn, Matplotlib, you cannot work on the machine learning project. Okay, so for exploratory data analysis, whenever you need to deal with the data, you must need to use these libraries. So these are the like mandatory one, right? So we can say it is collection of similar data type. So we'll see what is this similar data type, how it is, why we are saying it as a similar data type like that. It is a collection of similar data type. So we have seen heterogeneous data type, homogeneous data type, right? Similar, that means it's a homogeneous one. Homogeneous data type. What is the meaning of homogeneous and heterogeneous? Like
Contain same
same data type, right? If all integer are there, all integer will be there. If one value is like a float, all values will be a float only. It is not like that first value is 1, second value is 2.0, third value is a data. If like this is there, then all values will be converted to string like this, right? Again, what we are written, it is a collection of similar data type. Actually, it's written as a Numpy array. How it is written? Numpy array. It is created with the help of Numpy array, and that is a collection of similar data type. Oh, lot of spelling mistakes are there. Right. Similar data type. Second thing we can write, the Numpy array is what I'm saying. Numpy array. So it's an array. It's just like a list, like a structure, but it is in the form of array, which is faster than list. Numpy array is faster than list. We will prove this. Why it is a faster than list? Okay, I will prove this with the help of a time module. Date and time module we have learned. So with help of that, we will see how Numpy array is a faster than list. And actually it is implemented. Numpy is implemented in a C language. Implementation is in C language. Implementation is in C language. So these are the like basic things related to Numpy. You can find applications So some of the applications we have already seen, right? Applications, yes, where we have seen in statistics, we have implemented this np.mean, np.median, np.skewness, kurtosis, right? So we have used this before as well, right? So where we have used in statistics, we have implemented this statistics. Okay, in order to work with the linear algebra, okay, we will use this linear algebra. So we will use this in case of linear algebra as well to solve the simultaneous equation. Again, in matrix multiplication we can use it. 2D matrix we can form, and that we can multiply with the help of this numerical Python or Numpy array. Again, very important, it is used in image processing because your image is read as Numpy array, because machine or like computer is not understanding the directly image, so it is read in the form of numbers only. So those numbers are formed in the form of Numpy array only, right? In graphs we can use it. Graphs we can use it in a trigonometry. Whether we have seen the like examples for trigonometry or not yet? Whether we have covered the part of a trigonometry before?
No, sir.
No, not yet. Okay.
No, sir.
We'll cover this in the like Numpy module. In Numpy module, we will see all these things: matrix, linear algebra, trigonometry, all these things. Statistics also we will revise. Okay. So in order to work with this, you need to call it as a library, right? So how I am importing this? Just take a look. Import. What is the name of a library? Numpy as a NP. So as NP is nothing but just alias for it. Okay, NP is just alias. So whenever I am going to use it in a future, I will call it with the help of NP, that keyword. Okay, so these two characters I will use in order to call the NumPy. Is it okay? So it's just a short form or alias, right? So suppose I'm writing one list over here. List 1 is equal to, just take a look. List 1 is equal to, what we are writing? 1, 2, next number is suppose 4.5. Next is some word is there, data. And if I'm printing this, right? Print list 1, comma, type of a list 1. List 1, comma, type of a list 1. What it is printing? So it will be 1, 2, 4.5 as it is, right? No? All elements are printed as it is, right? But if I'm printing it with the help of array just a instance, ARR, just an instance, you can write anything, array 1, array 2, numpy array, like that. Array is equal to, how to create an array? np dot array of, what is the function? np dot array, which is a function of numpy. np dot array. What array you want to create? So I just want to create array with the same data. Okay, same data, and just print array, comma, type of array, comma, type of array. What it is printing, just take a look. So how it is printed? 1 in a quote, that means it is a string. 2 in a quote, that is it is a string. So whatever typecasting is possible, it will convert it into it to make it as a homogeneous. I hope it is clear.
Yes, sir.
String can, like 1 can be converted into a string, 2 can be converted into a string, 4.5 can be converted into string. That's why all the elements are converted into a string or object, right? And its class is a numpy.end array. So how its data type is identified? With the help of end array. Okay, how it is identified? With the help of end array. So you can write over here end array, which is n dimensional array. So what is the meaning of, what is dimensional? Okay, so there can be n dimensions, 1 dimension, 2 dimension, 3 dimension, that we are going to cover after that. But as of now, just try to understand. Right now it's a 1 dimensional and its type is numpy.end array. Suppose I'm creating the array with the help of a list. List 1 is equal to, I'm writing something, list 1 is equal to 1 comma 2 comma 3 comma 6.7. One element is a float. Okay, one element is float, and you are creating array with the help of this array is equal to np dot array of, you are providing argument as a list, right? List 1, and you are printing the array. So how it is printed, just take a look. Okay, print. How it is printed 1.0, 2.0, because one element is a float. That's why all elements are converted, all other elements are converted into a float only. Is it okay?
Sir?
Yes.
Yes, sir. Sir, array won't take a comma as a separator.
Array won't take a comma as a separator. Correct. You identified correctly. Array won't take comma as a separator. Though we are
Only
giving
white
input, though we are giving in input like 1 comma 2 comma 3 like that, but in array those are printed as items or elements only. If
Okay, sir.
if you are calling it, suppose you are not printing it. If you are not printing it, you are just calling it. There is some difference between printing and calling. That time it will show you array of these elements. But whenever you are using a print function, that time it will avoid this comma. Now you are calling this right now you know this difference. Is it in and out? This is output of a
Yes, sir.
seventh cell, right? So we have seen these things. There is some difference between calling the function and printing the function, or calling the object and printing the object. So whenever I am calling it, it will show the arrow commas, but whenever I am printing it, it will not show the comma,
Comma.
because it is printing the elements directly as an array only. And here it is showing me this is array.
Yes, sir.
Is it okay?
Yes,
Is there
sir.
any confusion, Prema, Bhavya? What about you? Done?
No, sir. No, sir.
Okay.
Yes, sir.
Now, as it is printing like 1.0, 2.0, right? Suppose I'm giving like this. Just take a look. Array is equal to, or here we can give a heading as well. I just want to change. Okay, change data type. Change data type of an array. Change data type of an array. Okay. Change data type of an array. Array is equal to np dot array of. Today, like by within 2 days, you will get familiar to this, how to create an array and all these things. Today it may be like it seems new to you or like newer thing, but you will get familiar. Don't worry about it. Okay. Np dot array of. I'm just printing 1, 20, 30, 40, and in output you just want it in a float value, right? So how I can give data type should be float. So which data type? Data type of these elements. Okay, and print this array. Print array. So how it is printing? 10, 20, so all elements are given in integer, but you are printing it in a float. Similarly, you can print these values in a complex as well. Is it okay?
Yes, sir.
So you can typecast like this, right? Again, suppose so integer to float possible, integer to complex is possible, right? If I want in a string, I can give a string as well. But if you are giving like this, suppose one value is 10 plus 6j, which is complex one, and you want values in a float, right? What it will show? Can't convert complex to float, because you already know int to float is possible, right?
Yes.
Int to complex is possible, right? Float to, yes, just tell
Into
me
string
why the
is
things.
possible.
Into string is also possible. Into string is possible. Any integer can be converted into a string. Similarly, float, same applicable to float as well, right? No?
Yes, sir.
Same applicable to float as well. The float to int, float to int, next float to complex, next
Float to
float
string.
to string, right? But complex to integer, complex to float is not possible. This type casting we already covered in a Python. Is it
Yes, sir.
right?
Yes, sir.
Next, suppose
String to int possible only if it is an integer.
string to int or float is possible only if it is a numerical value. Whole value is a numerical, right?
Yes, sir.
Okay. So now we will focus on the dimensions. As we are saying, it's a n-dimensional array, right? Na? Number of dimensions may be there. So now we'll see what is the dimensions in array. What are the dimensions? Dimensions in an array. So in that, first one is a zero-dimensional array. It's zero-dimensional array. Okay, very simple. So array 0, how we are creating the instance or a variable array 0 for understanding purpose only. It is not like you should write array 0 only or array 1 only. So for array 0, that means I am creating a zero-dimensional array. np.array of if I am providing like just a number, what I am providing just a number, array 0, how it is printed, array of a 3, how it is printed, array of a 3. If I am printing like this, just take a look, print array 0 comma array 0 dot ndim. What is the meaning of ndim? N dimensions. How many dimensions it is having? How many dimensions it is having? Or you can like specify like this also. Array is so and so, right? Array is so and so, and here you can write what you can write, dimensions for an array is like this. Invalid syntax, array is what is remaining, no, comma is remaining. Dimensions for an array is 0. Okay, so it just depend on the square bracket, how many square bracket or round bracket you are providing. On that basis it is depend. You are providing any value, suppose I am providing the value like 3000 also, so it's a 3000 single, no square brackets are there, square bracket are defining the dimensions, right? I hope spelling is wrong here also. Dimensional array markdown. Just execute this. Second is one dimensional array. What is second? One dimensional array. How many brackets you need to provide? You just need to provide two brackets over here. Okay, sorry, single bracket. So if I'm providing like this, if that element is enclosed by single square bracket, one like list inside a list we have seen. Similarly, if I'm printing like this, how it will be printed in a single square bracket and its dimension will be 1. So you can provide a number of elements as well. So here you can write array for understanding, array 1, one dimensional array, array 1 dot ndb, right? So just take a look. Array 1 provide number of elements over here. Array 1 np dot array of suppose 3 comma 5 comma 6 comma 9.0. So how it will be printed now? It will be printed 3.0, 5.0, 6.9, 9.0. Why? Because it's a homogeneous. It's a homogeneous. Single element is also there, then it will take a dimensions as a 1. Is it okay? If you are providing a single square bracket, it will give you the one dimensional array, right? Okay. Is it okay till now?
Yes,
Next.
yes, sir.
Next, suppose if I'm giving a two brackets for the same example, third type is two-dimensional array. It's a two-dimensional array. And how it is working, just take a look. Suppose for the same example, single element if I'm giving a two brackets, if that element or that object is surrounded by two brackets, I'm changing the instance name array2. Array is array2, array2 dot n dimensions. Array2 is a 3000 dimensions for array will be now 2 because it
Two.
is surrounded by
Two square brackets.
two square brackets. Okay, next. Suppose different elements are there. How it is printed, just take a look. 1 2 3 4 5. 1 2 3 4 5. Next, as two square brackets are there, we can represent the elements in a row and column format. Okay, so its meaning is actually 5 rows are there and single column is there. 5 rows and single column. If I am representing that array with the help of this, suppose in first row 1 and 2 is there, right? In second row, suppose if I am representing it like this, 3 comma 4 comma then 5 comma 6, 5 comma 6. So you can see 1 2 in a first row, 3 4 in a second row, 5 6 in a third row. It should be printed like this, right? If it is not giving you the proper structure, you can add backslash n in a print statement. Okay, in a print statement you can add a backslash n, so it will be printed properly. Again, just give a backslash n over here as well, so it will be printed like this. So these are the like just few things you can add. Backslash n or the escape character you can give in a print statement. First row, second row, third row. In a first row 1 and 2 is there, like how many dimensions will be there? 3 rows, 2 columns. 3 rows, 2 columns. It is represented in a rows and column format, 2 dimensional. For a table we are having the 2 dimension, those are the rows and column. So if I want to create the data frame from this, if you want to create a data frame from this, you can create a data frame as well in a tabular structure. Okay, so that part we will cover in a pandas module, but as of now you can see how we can create a 2D array. Similarly, we can create a 3-dimensional as well. So n dimensional array you can create. We need to work till 2 only, right? But if you want to create a 3-dimensional as well, you can go for the 3 dimensions. So fourth type is 3-dimensional array. So in 3-dimensional array, suppose how many brackets will be there? Simple. Suppose I am taking a single example, a single element over here, single element or single object, and if I am giving like this 3000 array, it's a 3-dimensional, so I am just changing the name 3 and again 3. It will be like this. Okay, suppose in this case array 2, and if you are giving like this, if I am adding just one bracket in beginning and one bracket at the end, how it is working? Array 3, array 3, array 3, array 3 dot n dimensions. So now its dimension is a 3, right? So you will get a good idea after working with the indexing and a slicing. As of now, how it is working, it is showing in a row and column format only, but you can see this whole 2D array is enclosed in a 3D array. So it's a single element for this, right now? As of now, this is a single element for this 3D array, right? So we'll see how we can convert the, or how we can work with the indexing in array. How indexing will work for the array. It will work in a similar way that we have seen for the list or tuple or sequence data type, string, positive indexing, negative indexing, that will work same over here. But it was like simple for the list. Suppose 1 2 3 4 5 elements are there. In this case, if it is like this, right? If it is a 3D array, and how indexing will work for a 6, if I want to fetch a 5 6 only, how it will work, that we need to understand. I hope till now it's okay. Any doubt
Yes,
till
sir.
now?
No, sir. Sir, so array works like matrix only.
Matrix only, but
It works
for
like
matrix we
matrix.
can say, for matrix it's a 2-dimensional always, right? No,
Yes,
for
sir.
matrix it's a 2-dimensional. only rows and columns will be there in matrix. But if I'm representing array like this, right, 3D array, so we cannot say it is a matrix. If it is a 2D array, we can say it is a matrix. Okay.
Okay. Sir.
Yeah. So for matrix, if we need to work with a matrix, we obviously we have to create a 2D array only, and that will be a 2D array only, rows and column format,
Okay.
obviously, right? So next part is indexing in array.
Sir, 1 second, sir.
Yes.
Sir, for n-dimensional also, that means like 5-dimensional, 6-dimensional also, it will be in rows and columns format only.
Not always rows and column format. Last 2 dimensions will be in a rows and column format. So we'll get idea after indexing and slicing.
Okay.
Of it. Still there is a doubt, we can discuss.
Yes.
But we'll complete indexing and slicing first. And still, if you have any doubt for the 4 dimension or 3 dimension, we will discuss on that. Okay.
Okay, sir.
Yeah. Indexing in an array. So initially I'm taking suppose a simple array, right? Suppose array is equal to 1-dimensional array. We will take np dot array of 1, 2, 3, 4, 5, right? Array. So it will print array like this. Suppose I'm fetching array of 0. What it will give you? 1 only, right? If I'm fetching array of 1, so what it will give you? 2. If I'm fetching array of -1, what it will give you? Last element, negative indexing, 5 only.
Yes. 5.
Is it okay? So positive, in a positive manner, this will be 0, 1, 2, 3, 4, length -1, right? In negative manner, it will be -1, -2, -3, -4, -5. Clear? For 1D, there is no issue, right? Okay. If same array is 2D one, if this array is np.array of, suppose 2D is there, first row, then second row, then suppose third row is also there. So how many dimensions are there? 2 dimensions are there, right?
Dimensions.
If you are printing this, just print it first, print array. How it is looking? First row, second row, third row, 2D array is there. For this, if I am fetching array of a 0, what it is giving you? The first row default. Default, what you are getting? First row, right? So what will be the length for this? How many rows are there? If I am checking, just take a look. Length of array. How much length is having? 3. So what will be the indexing for this? In a positive way, 0, 1, 2. Array of 0 will be your first row, right? Array of 1 will be your second row, is it? Array of 2 will be your third row. If you are fetching array of 3, just take a look. Array of 3, what it will give you? Index error. Index 3 is out of bound with axis size 3. Is it okay?
Yes, sir.
Default, it will give you the row for 2D only, right? Next, along with row, if you want to fetch column, I just want a 4 only, right now? It may happen. You just want to call 4 only. So in which row it is? In
One.
which row it is?
One.
0, right? So what I will call
One.
first?
1.
Sorry, 1. Array 1 I will call. And in array 1, what is the index of a 3?
1.
1.
0.
Or of 0?
0.
0. What is index of a 4?
1.
1. So if I fetch 1 of a 1, it will give me a 4. So how many time I need to decompose for a 2D? How many time I need to decompose for a 2D? 2 times, right?
2 times.
If you want to fetch a single element, if you want to go to the single element, how many time you need to decompose? 2 times.
times.
Is it okay till now? If it is a 2D array, if it is a single array, like it is a 1D array. So you just need for a single element fetching. To fetch a single element, you just need to call a single time. If 2D array is there and you need to go with the
2 times.
single element, to fetch a single element, how many times you need to decompose?
2 times.
2 times. Clear?
Yes, sir.
Till now? Now, if it is a 3D array, if it is a 3D array, how it will work. Or before that, we can go for the like positive, negative, some of the examples, right? Suppose array is like this. I'm printing one more array. Array is equal to np dot little bit bigger one, np dot array of. Suppose if it is like this, 1, 2, 3. First element is like this. Second one, 4, 5, 6. Next is 7, 8, 9. Like these elements are there. 2D array. And if you are calling it array, it will be like this 1, 2, 3, 4, 5, 6. Now, if I'm calling array of colon, comma, colon. So this comma is separating rows and columns. What this comma is doing? Rows and columns. What is the meaning of colon? If I'm fetching something with a colon, whole thing will be printed, right?
Yes, sir.
Yes, sir.
Default rows. So whatever there is before comma, right? What is its syntax? Rows, comma, columns. Rows and columns will be given. All rows and all columns. So your array will be printed as it is. Why I am showing this? We have fetched the single element, but what if I want 5, 6, 8, 9 only? Some part of the array, right? Slicing. 5, 6, 8, 9 like that. So if I'm fetching like this, just take a look. Array of colon. So all rows will be there, right? Colon, that means all rows will be there. And I just want the first column. What is output? 2, 5, 8. So all rows are there, right? 2, 5, 8. All 3 rows are there and first column, whatever column is there at first index, that will be given. Clear?
Yes, sir.
Prema, Bhavya.
Yes, sir.
Clear? Next, suppose if I'm fetching like this, suppose I just want a second index row and all columns. Second index row. What is the second index row? 7, 8, 9 is the second index row and all columns has been taken into the consideration. 7, 8, 9. All 3 columns are there. Now I want output as a 5, 6, 8, 9. Okay. 5, 6, 8, 9. How I can fetch? Just take a look. 5, 6, 8, 9. That means it's a one onwards all rows, right now. So can I write like this? 1 colon everything. Start at a 1 and end at a end. Whatever end is there for rows. So if I'm writing like this, what it will give you? As I have not given the as I have not given the anything for the column, it will print all the columns. 1, 2, 3 columns has been printed and row 1 onwards has been printed. Similarly, if I write 1 colon for columns as well, I will get 5, 6, 8, 9. Yes.
Yes, sir.
If I want left, like suppose leftmost element, right now, leftmost. Lastmost we can say.
Last.
Array last, right?
-1.
Just
-1.
-1, comma, -1. What it is giving? 9. Is it okay? Last
Yes.
row wise, last column wise. Clear?
Yes, sir.
Yes. Till 2D is it till 2D element? 2D array. Is it okay?
Yes, sir.
Till 2D. Now we'll focus on a 3D. How it will work for the 3D. For 2D, it's very fine. Rows and columns it will work, right? But same element. I'm taking same example. Purposefully, I will write over here. What? Indexing in 3D array. Indexing in 3D array. How indexing will work in a 3D array. Now just take a look. Control V, and I'm just converting this 2D into 3D. How it is printed? So 3 elements are there. Now just tell me, before this its length was a 3, right now? How many elements were there? 1, 2 and 3. How many elements were there? 3. List inside a list. Now you know what is the length of this array? 3 only, right? If I check length of this array now, what will be the length of this array now?
3.
Yes.
3.
3.
How many 2D array are inside? 2D arrays are there inside this 3D? How many 2D array?
2.
How many 2D array are inside this 3D array? 3D, that is a extreme one, right?
Yes, sir.
1.
No, 2, sir.
Okay. Saranya 2, Bhavya 1. What about you, Prema? I'm repeating question one more time. Huh? How many 2D arrays are there inside this 3D array? Now you know this is a 3D array, right? It is enclosed by 3 brackets. So how many 2D arrays it is holding?
2.
Which 2? Saranya?
One array we can see, sir. The other one is enclosed by the outer square brackets.
But this bracket is enclosed here, right?
3.
Yeah.
2, 3.
Prema 3, okay. Bhavya?
1, sir.
1 only, right? Now just pay attention. Huh? Array of a 0. Same way we will go. Array of a 0. What is array of a 0? What is array of a 0? So this and this extreme one are the 3D. Those are defining the 3D array, right? And what is inside this 3D? This is a single element which is 2D array. Saranya,
Yes, sir.
is it clear, Prema? If I am fetching array of 1, what it will show me? Index 1 is out of range because it is holding only one element, which is 2D1.
Yes, sir.
After
Okay, sir.
3D, there will be 2D, then 1D, then 0D. How many time I need to decompose to get a 6? If I want only 6, single value, how many time I need to decompose?
3 times.
3 times, right? 0, that is the first element. 0, that is a element. Then first row, 4, 5, 6, right? First row, 4, 5, 6 will be there. And in that 4, 5, 6, 6 is at second index. Then I will get a 6. Clear?
Yes, sir.
Yes, sir.
Now it will be more clear. Suppose if I am just redefining this like this. Now suppose if it is like this and this and again is there 10, 11, 12. Now same question. How many 2D arrays are there inside a 3D?
2. 2, sir.
Prema? Bhavya?
1, sir.
How many 2D arrays are there inside a 3D array?
2.
How many
2.
2D arrays are there? 1,
2.
this is, and this is second, right?
Sir,
So if I check,
Okay.
if I check length of an array now, length of an array, what will be the length of array? 2.
2.
So now if I need to fetch a 6, if I need to fetch a 6, how I can fetch? Array of
0.
array of a 0, it will give you the 0th element now. So what is 0th element? This one, whole 2D array, right? First 2D array. Then one will give you the 4, 5, 6, and then 2 will give you like this. If I need to fetch 11, right? How you can fetch? So this was for the 6, suppose. This was for the 6. If I need to fetch for 11, what I can write?
Array of 1.
Array of 1.
Array of 1, very good.
1
So
Again
7, 8,
one.
9, 10, 11. Then again
of 1.
of 1,
Yes. Array. Then
Of 1.
again
No,
1.
no,
So step by step you can perform. What is the output? What is the output? That way we can decompose. I hope it is clear now. So if it is a 3D array, we can take it as an element first. So whatever is there, first thing you are fetching, that is an element, and last 2 will be rows and columns. Clear?
Yes, sir.
So for any array, if it is a 5-dimensional, if it is a, how many dimensions are there?
5 dimensions.
If it is a 5-dimensional one, so how it will be there? Key first, second, third will be the elements. Element inside element, element inside element that you need to work. and then you will find
Right.
rows and columns. Then you can define with the help of rows and columns. So for any array, for any n-dimensional array, last two things or last two numbers will be of rows and columns only. And before that, we can call it as elements. Element inside element, element inside element, or array inside a array, array inside a array, like this. So if it is like this, suppose it is a one-dimensional array. If it is a 1D array, if it is a 1D array, we can form a multiple zero-dimensional or zero-dimensional arrays. Multiple zero-dimensional arrays. If it is a 2D array, if it is two-dimensional array, you can form a multiple one-dimensional array. If it is a 3D array, you can form a multiple two-dimensional array. If it is a four-dimensional array, you can form a multiple three-dimensional array, like this. Is it okay?
Yes, sir.
Yes, everyone?
Yes, sir.
Yes, sir.
Any doubt till now?
No, sir.
No? Everything is clear.
Yes, sir.
So 1-to-1 slicing also you can work, right? You can
Yes, sir.
easily work with the slicing as well. Next, I just want to discuss. So for 3D, is it clear? For three-dimensional? For 2D, it's very fine, right? It's very simple till 2D, but I hope for 3D also you got the things,
Yes, sir.
right?
Sir.
Now we will discuss one more part, that is how I have written like this, right? Numpy array is faster than list. How Numpy array is a faster than list. We need to prove this with the time model. You will find this very interesting, right? Suppose I'm having one list. List 1 is equal to, okay, 1, 3, 3, 4, 5, and I just want a result. So result is like, what result we want? Result is equal to 1, 4, 9, 16, 25. Okay. So how I can print this result?
Square.
Square root.
Squaring, right? How to square it? How to do this square?
For I in list 1,
Hmm?
in print, I mean, we'll put num as square root of I, and then print I in result.
Power.
There are a number of ways to do it, right? Na? We can
Yes, sir.
store the result as, I can store the, like, number of ways we can do it. Result is equal to empty list. Then I can print
For I in
for I in
list 1,
for I in list 1.
I is equal to I
result-
square.
Right. You can write this also, right? Na? Result dot append I square. Is it directly you can append the I square in a result
Yes, sir.
list, and last you can print
Result.
Result.
as it is. Result we can print. Just print the result. So what it will print? So this is one way. Again, same code we can write with the help of least comprehension as well, right? How to write with the help of least comprehension? I square, yes, I square for I square for I in list 1. This is another way, right? So these are the two ways those we can use. So if you want to generate a square of a list, you need to write a program like this. Is it?
Yes, sir.
If I am writing like this, just take a look. List 1 into 2. What it is printing? So it is doubling that list. Elements are doubled. Objects are not doubled.
Yes, sir.
Individuals are not double. List is doubled, right? 5 elements were there. Now it's having 10 elements, right? If there is a Python word, there is a Python word and you are just hitting 5. So how many times Python has been printed? 5 times.
Yes.
Same code, same work we are doing with the help of NumPy array now. Just try to understand. Array is equal to np dot array of just take a look 1 comma 2 comma 3 5 and you want the same result, right? If I am printing array into 2, what result you are getting? Take a 5 argument given. What is remaining? Bracket is remaining, one dimensional. How it is printed? So whatever function you are doing, that is applied on objects,
Each and every
not
element.
whole the array, right? Individual elements it is working. So that's why it is playing a faster role because elements has been considered, right? So if I want to create a square, of this array, what I can write? Just give power of array power 2. So it will print a square for you. There is no need to write a for, no need to go for the iterations, no need to go for the appending the things like that. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Next, you can perform any operation. Suppose I just want in each element, I just want to add 5. So it will add a 5 for you, 6, 7, 8 like this. If you want to divide each element by something, array divided by 2, how it is working? 0.5 like that, right? Is it okay till now?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now we will try to implement it with the help of date time module, right? How much time it is taking to perform the operation with a list, and if we are doing the same operation with the help of array, how much time it is taking. So that we will see now, right? Suppose okay. So I'm just importing time over here. What do we need to import? Import a time, right? From date time module, we have imported the time. Before starting the program, I am just defining the start time is equal to
Sir, no
start
need to
time.
mention import time from date time.
No, there is no need to mention a date time because it will just subtract the date time for us. Today's date it can take whole date. If it is taking whole date, no worry. We just want a difference between the two times. Before starting the program and after ending the program, what is the duration? So there is no need to call it from the date time, like particularly time only like that.
Okay.
We can take that way also, but
We are calling that. We are
we
not
just want a
calling-
difference. We are not going to print it in any format. I just want the difference between the time value. Suppose right now it's 7:53, right? 7:53, 30 seconds. And after execution of this program, there is a 7:54:01 second. So what is the difference of those seconds only?
Okay, okay, sir.
So that I want, right? So start time equal to how I can define time dot time will be taken into the consideration what is the time of a system right now. So what will be stored in a start time? Whatever time right now. Okay. Is it okay?
Yes,
Yes, sir.
What this start time will store? Whatever the time right now is there, right? Suppose I'm having one list. I'm printing list is equal to, suppose new list is equal to something, a regular program with the help of list comprehension. What I want, I just want the square of each element, I square for I square for I in range of 100k. Suppose what value we are taking? 100k. And time taken for this program, suppose I'm taking it as an end time. So to execute this thing, what thing? New list. In order to print this new list, end time is equal to again time dot time. I hope you got this.
yes, sir.
Yes,
What
sir.
is the time before starting this code and whatever
After
time that is
execution.
after execution of this code, right?
Yes,
So I can write time taken would be time taken Suppose time taken is equal to
Start
n
time
time.
minus end.
Very good. N time minus start time will be the time taken. And print. So there is nothing to do with this one, time taken print. What we are storing, this thing only, these three, right? So execution or time taken for execution is time taken for execution is suppose time taken only. Okay, so how much time it's taken? 0.25 seconds, like that. Is it okay? Right? For a regular programming with the help of list only. Suppose same code I'm executing, I'm just copy pasting it, right? New list is equal to, you have created one list, but I have created it with the help of
Array.
List.
array. np dot array
Array.
np dot array of. Now it's not a square. I'm printing for like I for I in a range of 100k. And what do you want? New array or a new list, whatever you can write. Suppose it's just an array only. First, it's a array, and new array is equal to, what is a new array? Array square, right? Array square. How much time it is taking? Invalid syntax. I for I. Okay. Bracket, square bracket, and close by round bracket. How much time it is taken?
0.
For the same code, 0.05. So it's near about 5 to 10 times faster than a list execution. Yes. Is it okay?
Yes, sir.
I hope you got this. Why NumPy array is a faster than list? It works on elements. It work element wise. Clear?
Yes.
Saranya, Prema,
Yes, sir.
okay. Is it clear?
Yes, sir.
So just do practice for these things. Like try to get the things, basic things for the NumPy first, and we will continue with the NumPy functions for the next 2 days. Right?
Yes, sir.
We'll take it like slowly for right now, because it's the beginning of machine learning thing. Try to print the arrays. Try to understand the indexing and slicing. Very important. How it works for the 3 dimensions. Right? So that's all. Thank you.
Thank you, sir.